Hello guys. Um, Basically today I'm going to show you guys every single way of solving solubility product question or solubility constant question, whatever that they ask in CIE A level exams. I have a few questions here, and I think if you study these 5 or 4, you can easily answer every single one of them. Anyways, let's start. Uh, Phosphate ion containing Ca+2 and a precipitate of calcium phosphate. Okay, write an expression for the KSP of um, calcium phosphate, right? Calcium phosphate. So for whenever they ask you for the expression, all you have to do is basically separate the precipitate into ions. Like basically, whatever ions they form, it's basically going to be the formula, like basically the expression. So for example, here we have 3 calcium ions, right? 3 calcium 2 plus ions, and we also have phosphate 3 minus ions, right? So we use these 2 ions to actually form an expression. Now we have 3 calcium 2 plus ions, therefore we square it, we cube it by 3, and then we have 2 phosphate ions, therefore I apologize here, it's actually plus 2. And here you just square it by 2. And this is basically going to be question I. This is how you answer question I. It's very simple. I think we're going to go over a couple of times like other questions where you do the same exact thing. Solubility, okay, the next question, the solubility of the precipitate is 2 point whatever, they gave you like a value here. And this is at the temperature. Okay, calculate the solubility product KSP of calcium phosphate at this temperature, include the units. Okay, whenever they give you the solubility, right? Whenever they give you the solubility, you're basically supposed to use this as the X value, or how can I say it? As the ion, solubility value. So to basically find the KSP, normally you'd expect to have the concentration of ions that the precipitate is formed from, right? But then if you don't, you just use the value of solubility that they give you for the entire compound. So let's do that let's do exactly what I just said. So uh, okay, and I think the biggest tip I can give you guys is to solve it in a different way. So look, also another thing, when they give you solubilities, right, you have to multiply the number of ions present inside the brackets as well. So for example, here there's no 3 Ka2 plus 3 squared, but then when you're actually calculating the KSP, you're supposed to do it. But since we don't have like individual ion concentrations, we can simplify both of these ions as S, or we can simplify them as X. Basically, make them make the value of solubility as a subject of X or S or any letter. Basically, this simplifies the process much more. Therefore, and then we can combine them much more like easily. Either ways, let's start. So for calcium, right? Let's start with the KSP. Uh, let's say the solubility is S. Solubility is S. It's 2.5 multiplied by 10 to the power minus 6, right? This is the solubility. So for calcium, we have 3 calcium ions. Therefore, we're going to do 3 calcium ions multiplied by solubility to the cubed. The second part is phosphate ions. Since we're basically using one solubility value to actually calculate the rest, we're going to have S as well. But there's 2 phosphate ions, therefore 2 multiplied by S, which is solubility, and squared. This is exactly how you're going to do this. Now you combine them using simple maths. You can combine them through simple maths, which okay, if you square if you cube 3, you get 27s cubed multiplied by 4s squared, and then you can multiply this. What do you get? Let me just check, just one sec. 108 S5. I think this is the simplest way to actually do it. Now all you have to do is basically plug in this value over here, and you just plug it into the S here, and you end up with a value of 1.2.5 multiplied by 10 to the power 6 to the power of 5, which gives you 1.05 multiplied by 10 to the power minus 26. Okay, this is the KSP value, right? They also asked us to find the units. Oh, always write 3 decimal places. Anyways, they told us to find the units as well. So the unit of S is mole dm cubed. Now what happens if you have the power of 5? All you have to do is basically mole dm cubed, multiply this by 5. Basically adds a power 5 to mole, and you also multiply this by this multiplied by this becomes minus 15, and that's basically the answer. Mole 5. Whoops. I mean, when I used to do this, these used to be like free marks, so to you guys as well it should be free marks. Anyways, uh consider, okay, this is another type of question. I think this is very similar to the one that we just did. The first thing you should do is form, uh, even though they don't ask you to form it, you should always form it, you should always form the KSP expression. The equilibrium constant for EI or whatever, they gave us the KSP. Oh, okay, so here they gave us the KSP, right? The equilibrium constant, calculate the solubility. Okay, when they're asking for the solubility, it would be the reverse process of this. It would basically be the reverse process. So therefore, we're basically going to start with KSP multiplied by S and S. Both of these would be considered the same because they're not asking us for individual ion concentrations, right? So if you don't have individual ion concentrations, we just use the solubility of the precipitate. Therefore, this is going to be S squared, and it's going to be equal to KSP, which they already gave us. Now, all you have to do to find the answer, which would be the solubility of Ag, is basically square rooting the KSP value for equilibrium 1, which is mentioned here. There's two equations, right? We're basically only involving ourselves, we're only dealing with the first one, because the equilibrium constant for, they basically asked us to find the solubility of AgBr. There's no AgBr in the second equilibrium, so ignore this. We just have to deal with the first one. So in equilibrium, I mean, to find the answer is basically like extremely simple. You just square root it, and you end up with the value, which is 7.1 multiplied by 10 to the power minus 7. I mean, if you're using 3 decimal places, of course, I think it's better to use 3 decimal places. But yeah, this would be the answer. Yeah. Let's say if it was S3, right? What would you have to do to get the solubility? All you have to do is basically KSP 3 in your calculator, and this gives you the value of S. It's really that simple. Anyways, next question. An aqueous solution of lead nitrate is mixed with an aqueous solution of sodium iodide. A yellow precipitate of lead iodide is formed and filtered, leaving solution X. In solution X, there is a concentration of lead, which is this, and they also gave us the concentration of iodine in solution X, which is this. Use these data to calculate the value of for the solubility product of KSP of lead iodide. Now notice they didn't give us the solubility value. I mean, they didn't give us the solubility value for PbI2, right? They didn't give it to us. All they're asking us is basically to find the KSP, right? They're asking us to find the KSP. Now, how would you do this? Using the individual concentrations that they gave us, right? When they give you individual concentrations, you don't have to multiply inside the bracket. So it's going to be exactly the same as the expression. So there's no, so for example, over here, we had to multiply, I mean, where's the, yeah, over here, let me just change the color. Just 1 second. Just change the color of my pen. Where is it? Yeah, right. Over here, we multiplied it by 3 because there's 3 calcium ions, there's 2 phosphate ions, but then this is due to this is only because they gave us the solubility value, the concentration of I mean solubility value of calcium phosphate. But if they don't give it to us, we don't have to do any of that. We just have to form the expression, which is KSP Ag plus iron. And sorry, I really apologize. I'm a bit sleepy. Anyways, let me just start over again. They gave us Pb2 plus, right? And two, iodide ions. Now, another tip I would give you guys is, honestly, when they give you these type of questions, you have to focus um, on the compound that they give you. Like for example, you can't just ignorantly write squared or whatever. You have to look at the equilibrium equation, which is basically this. This is the compound, right? Led to iodide. If we have 2 plus here, and we have iodide ions, how can you balance them? You have to multiply iodide by 2, right? Of course. So therefore, you have to keep this you have to keep this in consideration. If you don't, you're actually gonna mess up the question. Either ways, so all you have to do now is basically plug these two values inside the equation. So you end up getting KSP is equals to 5.68 multiplied by 10 to the power minus 3 multiplied by 4.2 multiplied by 10 to the power minus 4 squared. And this would give you the KSP value, which is, let me just calculate it real quick. I have holidays, but I'm still doing this. Either ways, yeah, this gives you the values of 1.0 multiplied by 10 to the power 9. So this would be the KSP value. Now to find the units, it would be similar. Like all you have to do is basically mole dm cubed multiplied by mole dm cubed, because they already gave us like the units here, right? But all we have to do is basically square them according to the expression, KSP expression. We have to just square them. So this basically becomes, this is similar to writing mole dm3 cubed, because you can combine these two. This is basically 1, this is 2. They have the same base, therefore you can just add them and it becomes cubed. Now cube them, mole cubed multiplied by dm39, and that's the answer. It's pretty simple, really. I think this chapter is so easy. Like, okay, let me change my pen color. I'm getting bored of this. I mean, not bored. I'm just getting tired of this color. It's like too. Just makes me sad, innit? Either way, an orange precipitate of HgI2 forms when Hg2 plus ions are added to Ki ions. Okay, the solubility of Hg2 I2. Okay, the solubility of the precipitate at 25 degrees is this. Calculate the solubility product of Hg of the precipitate. Include units in your answer. Okay, guys, I want you guys to notice something very carefully. They didn't give us mole dm3 concentration. They gave us something in gram dm3. So how do we convert this to mole? All you have to do is basically divide it by the mr. So whenever you see some additional information added into the question, always look back into the first point that they mentioned. Like always look back, because you might miss this and you might just ignorantly do the equation as if you had mole dm minus cubed, but then you don't. You have gram dm minus cubed, so you always have to, recheck. If you don't, you might make a big mistake, and then this could screw you up in the exam. This could like ruin your A. This could take your A to a B plus, man. I mean to a B. So please don't make this mistake. Either ways, let me just go back to the point. Anyways, to convert gram dm cubed to mole, all you have to do is divide it by the mr. So for example, we have 1.0 multiplied by 10 to the power 7 gram dm cubed. We have to divide it by the mr, which is 454. 1 multiplied by 10 to the power minus 7 divided by 454.4. This gives you a value of 2.2 multiplied by 10 to the power minus 10 mole dm cubed. Yeah, mole dm cubed. Now we can calculate the solubility product. Since they gave us the solubility of the whole compound, we have to, in the expression, it's basically going to be Hg 2 plus and I minus 2 squared, right? But then since we have the solubility of the whole compound, we can basically unify both of them, and we can form S multiplied by 2S. Remember, we have to multiply it inside the bracket since we have the solubility of the whole precipitate, and we have to square this. Therefore, this becomes S multiplied by 4S squared. 4S squared, right? Yeah, 4S squared multiplied by 4S3. Now, they gave us the solubility, so all you have to do is basically plug it in, cubed, and this should give you decent, this should give you a good amount, I think. This should give you a good number, 3. The value, they didn't ask for the unit, so I guess you don't mention it. I don't know if you lose marks. Oh, sorry, they did ask for the units. I really apologize. To find the units is pretty simple. I think you don't need to use this. You just need to use mole dm cubed as, like, just follow the original KSP expression, and then mole dm cubed squared. This becomes mole dm cubed cubed, and then the units is basically going to be mole 3 dm minus 9. Yeah. Okay. And then last question. I think this is the last type of question that they kind of ask. This is probably the one question that really bothered me when I was doing past papers back in A levels. I remember I hated this question because it was just too complex, and I always used to get it wrong. If I didn't practice this question, I would be unprepared for the exam. Either ways, KSP, they gave us the KSP, which is whatever. They gave us the value. I'm not writing it. Too lazy. Calculate the KSP. Okay, calculate the value of the solubility of BAS4 in G per 1. Okay, in grams per 100 centimeters of solution. Okay, interesting. Very interesting indeed. Ow. Okay, so I think let's start by finding the solubility of barium sulfate. I think that's the first thing that you guys should do. So KSP, and also since they're asking for the solubility of the whole compound, we can just unify them. There's no need to multiply. There's no need to have there's no need to find specific ion concentrations for barium or sulfate ions. So we just have to unify them. So by unifying, of course, just considering them as one letter, making them the subject of one letter. This becomes S, and we also have sulfate ions, which is -2. This also becomes S. Therefore, we end up with S squared, right? We have the KSP. All we need to do to find the value of S is basically square rooting this. Understand? You end up with, and also you have to take care of the units. I think units play like a big part in these type of questions. Wait, let me just convert this. 1.04 multiplied by 10 to the power minus 5. So here we end up with mole dm cubed, right? We end up with mole dm cubed, but then we're looking for grams per centimeter per 100 centimeters, right? Per 100 centimeters, which is basically grams 0.0 dm cubed. Okay, we're gonna look into this later. Just give me a second. Anyways, to convert this to grams, we have to do the reverse of what we did here. For example, here we went from grams to moles, right? So looking back at the equation or the equation to find moles, it's basically grams divided by mr, right? So if you want to get grams, all you have to do is multiply moles by mr. So the mr of barium sulfate is I think the mr is 233.4. I'm not sure, I don't remember. I'm pretty sure this is the answer anyways. So basically you have to find the mr. All you have to do now is basically multiply this value, which is the solubility, multiply it with this. This should give you a different value. Let me just calculate it real quick. 234, which gives you, okay, yeah, okay. Let me just go back. Yeah, 242. Sorry, 243 multiplied by 10 to the power 3 grams per dm cubed. Okay, now this is the last part. How do you go? Okay, 1 dm cubed. Okay, dm cubed is basically similar to, how can I say it? It's basically similar to this. Yeah, I'm pretty sure it's basically similar to this. So yeah, it's like very similar. It's basically like 1,000 liter. Sorry, 1 liter. Or no, it's basically similar to 1,000 liter. But then if you want to convert, but okay, let me just not make this confusing. Anyways, if you want to go from dm cubed, which is approximately 1,000 centimeters squared, you basically, all you have to do is basically divide by 10, which gives you 100 centimeters. Therefore, you end up with, all you have to do here is basically divided by 10. You end up with, divided by 10, sorry. You end up with the same number, I mean 2.43, except with a different power, which is 10.4, minus 4. And that's it. I think that gives you the answer. Pretty damn simple. And anyways, I think if you practice these 4 questions that I just did, and you go through as many past papers as you possibly can, I think answering KSP questions is like light work. I think it's extremely easy. And if you guys have any other topical questions that you want me to review and make it like, make it fun, make studying fun, then let me know, please. Thank you. Thank you guys for watching, and make sure to tune into other videos. Thank you. Assalamu alaikum.